We don't want solo. That would be bad. We always have our 1/2 base times height thing, but what was the new kind of way of finding the area that we talked about last time?
1/2 BC sin A.
No, it didn't have cosines in it.
1/2 BC sin A.
We talked about the law of cosines, but how can we find the area of a triangle?
Through a new formula?
Yep. What was that new strategy?
1/2 side included.
Sine of included angle. So 1/2 side sine. So 1/2 side times sine of included angle. So if somebody says to me, find the area of this triangle, this is the first problem we're doing here, number B, letter B. Find the area of this triangle, what's missing? Well, I don't have a height, so I don't have any angles, right? If I had an angle, would I be able to find the area of this triangle?
Yeah.
Yeah, really easily. So let's find an angle. All right, how are we going to do that? How are we going to find an angle in this triangle?
Law of cosines?
Law of cosines. So Bronson, since you're all over this, which one do you want to find? Does not matter one bit.
Angle A.
Angle A. Here we go. We're going to find angle A. So if we're going to find angle A using the law of cosines, then 15 squared is over here, right? 15 squared equals what? What's the law of cosines say? 15 squared equals what?
18 squared?
18 squared
13 squared.
plus 13 squared minus
2.
18, 13 cosine A. Everybody okay with that? That's my law of cosines. These are the ones, I know you guys are all good with your calculators, but just be careful because this mess right here is hooked to the cosine, so you can't combine it with the other things. So just don't get going too fast. I'm going to go ahead and subtract these guys over. So over here I have negative 268. And then I'll go ahead and multiply those. And I have 468 negative. All right, so double check my work there. What do you think? Did I do okay there? Oh, 15 squared minus 18 squared minus 13 squared, okay. And then 2 times 18 times 13, yeah. Is that all right with everybody so far? So then what do we need to do? Divide, so we have 268 over 468 equals cosine A. And then how do I type that into my calculator? Inverse cosine, yep. So I'm going to inverse cosine that number, 268 over 468. And angle A is 55.06 degrees. Is that okay with you? So remember, our objective was to find the area. Can I do that now? So the area will be 1/2 13 times 18 times the sine of the angle that's in my calculator. So 0.5 times 13 times 18 times sine second answer. I got 95.92. And I'm actually, just for fun, gonna write out a whole bunch of places there. I wouldn't do this normally, I would say 95.92. But we're gonna do something here, and I want you to see, which is cool. All right. Now, next time you see a problem like this, you probably aren't going to go to all this trouble. You can, we got the answer, and it's perfectly okay. But there is another area formula that is so slick and handy perimeter of the triangle. So in other words, if you have all three sides of your triangle, you can find the area really in a snap. Here's how it works. What is the perimeter of this triangle?
46.
46. So the perimeter is 46. Now, once again, guys, this strategy that we're getting ready to do only works if you have all three sides, okay? Otherwise, we're gonna do 1/2 side, sine, which we can do here too if we want. If the perimeter is 46, the semi-perimeter would be what? What do you think we mean by semi-perimeter?
Sides.
What's a semicircle? Half the circle. What's a semi-perimeter? Half the perimeter. So my semi-perimeter is 23. So this area formula is a radical. I'm going to give you the actual formula in a minute, but right now we're just working through it. And the first number under the radical is the semi-perimeter of the triangle. Now, take that semi-perimeter, that 23, minus each side. So 23 minus 13 would be 10. 23 minus 15 would be 8. And 23 minus 18 would be 5. And that
Good
number
morning,
right
Khadija.
there,
At
type
this
that
time,
in
if
on
you
the
have not already done
calculator,
so,
and
please
this is what
release
you're
all
gonna do.
concert choir and liturgy to the rack for Ash Wednesday Mass. Thank you.
All right, so if that's any of you, go ahead and go. Compare what I wrote down, maybe it's still on your calculator too, with what I get when I multiply all these numbers together and take the square root. Isn't that slick? Some guy named Heron of Alexandria developed that formula. We now refer to it as Hero's formula. His name was Heron, H-E-R-O-N. Now called Hero's formula. And Hero's formula says that the area of the triangle, the area of the triangle is the square root of S minus A, S minus B, S minus C. So this is on the next page of your notes. S stands for semi-perimeter. And A, B, and C are the sides of the triangle. So clearly, this formula is only going to work if you have all three sides, because you need the perimeter. Okay? Wow. That is so awesome. That is so awesome. All right, anybody have a question about this? So we did it the long way first, which is absolutely fine. You can always do it that way, 1/2 side, sine. Caution, if Bronson would want to find side or angle B first, then it would be 1/2 13 15 sine B, right? Always use the angle between the two sides that you're using, if you're going to use this formula. Okay. Next problem is a weird shape that you are going to find the area of. So we've got this. And you're going to find the area of this. Okay. What do you think about that? Do you have any kind thoughts about that? Ben?
You could split it into triangles.
Oh, what a great idea. Weird shape, don't know how to find the area of something like that, but I do know how to find the area of triangles. So Ben, think about this for a second. You've got two options. You could draw in the short diagonal here, or you could draw in the longer diagonal.
The short diagonal, because you use Pythagorean theorem to solve.
Okay, so I'm with you. The short diagonal is gonna create a right triangle, and right triangles have options that other triangles don't, like the Pythagorean theorem. So I'm gonna call this triangle 1, and this triangle 2, and the area of the whole thing is gonna be those two areas added up. So, the area of triangle 1 is a no-brainer, because the area is 1/2 base times height, and base and height are the two perpendicular sides. So that area is just going to be what? Is that 2100? Square whatevers. Did I multiply right there, guys?
Yep.
Okay. Like, that's the easy one. Now, Ben, I heard you say something about the Pythagorean theorem. So we certainly could find that blue line I drew, the hypotenuse. So 60 squared plus 70 squared. Square root of 8,500, I'm just gonna leave it as the square root of 8,500. Wow, I have two sides, look at triangle 2. I have two sides of the triangle now, don't I? The area will be a cinch if I have what? What else do I need? The angle in between them. Now be careful, the angle between them is this orange thing, right? It's not 108 and it's not 54. Right? We're not gonna make any assumptions about bisecting the angle and all that. We can't. So how in the world am I gonna find that orange angle? If I had it, I'd be all set. Ben? Jones?
You can do the inverse tangent of 70 over 60.
Oh, don't we love our right triangles? Ben says, forget the orange one, I'm gonna find the red one. I'm gonna find this red angle right here, I'll call it X, because the tangent of X is 70 over 60. So he said second tangent, inverse tangent, 70 over 60. Okay, I can do that. So inverse tangent, 70 divided by 60. I got 49.40 basically. But it wasn't the red one we wanted, right? It was the orange one. But we can find that by just taking 108 minus the one that's on my calculator. Did you get 58.60? So now we know our orange angle is 58.60. And now can we find the area of triangle 2? Yep, it'll be 1/2 the square root of 8,500 times 98 times the sine of 58.60, which I don't even need to round that off because it's on my calculator still. So 1/2 times the square root of 8,500 times 98 times sine answer. Did you get 3856.03? So the total area is 5956.03 square centimeters. Nicely done. Ava, how do I feel about people doing non-math in math class? Not good. Stop it. Okay, very nicely done on that problem though, very nicely done. Okay, next. Tony must find the distance from A to B on the opposite side of a lake. He locates a point C, okay, so the picture's all drawn there. Find the distance AB. Oh, this is easy compared to what we just did. What do you think? I'm not gonna draw the lake and all that, but I know this is 860, I know this is 78, and I know this is 175, and I wanna find this. Sam?
Could you do the law sign? Or, yeah. The law sign.
Well,
X.
when we find a side of a triangle or an angle of a triangle, we either use the law of sines or law of cosines. Now, I don't think sines is gonna work in this case, because why? Who can explain why sines isn't gonna work, Jennifer? Well, and you don't necessarily have to have two angles, but you have to have a ratio. Yeah, you have to have, Sam, look, I have to have either this pair, or this pair, or this pair, and you see that I don't? So if and it's okay, if you try to set up a law of sines, you're not gonna be able to solve it, because it's gonna have too many variables in it. So if the law of sines won't work, then we're gonna need the law of cosines, right? And our angle is 78, so we're gonna have x squared equals 860 squared, 175 squared, 2 times 860, what that is, times 175 times cosine 78. Now, I've been doing the law of cosines for a very long time, you have not. Take a look at that, are you okay with that? That makes sense to you in terms of the way the law of cosines works? This is an easy one to type in because the variable's all by itself. The only tricky thing here is remember to take the square root after you get it all multiplied out. I got 841.22 feet. Double check my work, make sure that's right. Okay, good. Okay, now we have a navigation problem. So we gotta be careful about our setup now, make sure we're following the rules of navigation. All right, so two planes flying together in formation take off in different directions. All right, so here's the airport. One flies due east. So here we go, due east at 350 miles an hour, and the other flies east northeast. Okay, so I'm gonna put that would be northeast. Would you agree with that? So east northeast would be this one. And how big would this blue angle, or this angle right here, how big would that be? 22.5, very good. Everybody clear on that? All right, what do I know? How far apart are the two airplanes 2 hours after they take off, assuming they fly at the same altitude? Okay, so how long is this black line I drew right here? This is the due east airplane. How long is that, Bronson?
700.
700 miles. Everybody okay with that? And then how about the blue one? How long is the blue one?
760.
760 miles. And I want to know how far apart are the airplanes. Would you agree with that? Okay, go ahead and set it up. Like Sam and I were talking a minute ago, when you're finding a side of a triangle, you're going to use either law of sines or law of cosines. That's how we find sides of triangles. So figure out which one it is. And set it up. So Natalie, what do you think? We gotta use sines or cosines here?
Cosine.
Yep, and how'd you set it up?
I did x squared equals 760 squared plus 700 squared minus 2 times 760 times 700, and then the sine of 22, or cosine.
Cosine, yep. Cosine 22.5. Does that look all right to everybody? And Natalie, what'd you come up with as your answer? How far apart are these planes?
I got 290.85.
So did I. Good job. Everybody okay with that? Right, now we're gonna do one that's a little bit interesting. A new vocabulary word, you may have talked about this in geometry. When we talk about a segment of a circle, what we're talking about, okay, so first of all, this is called a sector. A piece of pie is called a sector, okay? When you draw that chord in there, that splits that sector into a triangle and then this little thing. This little thing is called a segment of the circle. That's called a segment of the circle. And your job is to find the area of that segment. If we know the circle has a radius of 5 and the chord has a length of 7. The area of the segment is going to be the area of the sector minus the area of the triangle. Would you agree? So to get our answer, we're going to have to find the area of the sector and the area of the triangle and then subtract them. Okay, so what do you think? Drew?
Law of cosine, since the other side is 5 as well.
So we could use the law of cosines to find what? What would I be finding?
I don't know what it's called. The central angle, I guess.
The angle, yeah. I could find that angle right there. Would everybody agree with that? Now, is anybody wondering why he's finding that angle? Drew, why are you finding that angle?
Because you can find out how much a 360 is.
Exactly. That's going to give us the area of the sector, right? We need that angle for the area of the sector. So, here we go. Law of cosines. What's that going to look like? Who can set that up for us? Okay, I will. 7 squared equals 5 squared plus 5 squared minus 255 cosine x. Is that okay with everybody? So here we go. Be careful typing this one in. These are the ones you have to pay attention to what you're doing. I got 88.85. Anybody else get that? For that angle? Nod.
Yes.
Thank you. Thank you. So now, Drew, what did you say we did that for? We found that angle, so we knew what? What does that tell us?
You can like, I think you can divide it by 360 or something. I can't quite remember.
Well, this piece of the pie is 88.85 3/60ths of the whole circle. Would you agree with that? And the whole circle is 25 pi r squared, the area of the whole circle. So the fractional piece that I'm getting is 88.85 over 360. So I'm just going to take the number, the number that's in my calculator. I'm going to divide it by 360 and multiply it by 25 pi. And the area of the sector is 19.38. Now how about the triangle? Well, since you've already found this angle, can we find the area pretty handily here? 1/2 5 sine angle. We could also go back and use Hero's formula, which is great, but I've already got that. I would definitely do that if I didn't have the angle, but since I already have the angle, I'll just do, shoot, I don't know what I was pressing there. I'll just do 1/2 times 5 times 5 times sine 88.85. And I got, for the triangle, I got 12.50 basically. Nod, shake, okay. So my answer is 19.38 minus 12.5. So the answer is 6.88 square inches. Okay. All right. So tomorrow